Alright, let's have a look at our last lesson for financial maths. The question said, and this was the paper F1 in the 2024 booklet, which was the GDE final paper of the end of 2023. So if you wanted to look for that as well, it's our school's paper, not our school's, our country's paper for the end of last year, 2023. So question 6.1.1 said, if I can look at the sum, I can remember what it was. It says that the guy is putting in 18,500, and at the end of 6 months, he has 19,319,48. What is the interest rate? They want to know what is R for interest rate. So when I put that all into the formula, you should know that that is a grade 11 question because there was one amount. He put in 18,500 in the bank, he left it there for 6 months. That's why it's not a grade 12 sum, because he didn't pay constant installments. So to do the sum, it's just a matter of which step goes before which one. First step, you say 19,000 divided by the 8,000 something, and it gives you 1,044 what. Do not round off. On the other side, you've got your bracket to the power of 6. So what do I need to do first there? Get away the fix the exponent by doing the root. So it's a 6th root. You don't have to show me that. 6th root of that answer would give me the 1 plus I. I should actually have a 1 plus I still there, which then would give me 1,00. It doesn't look a lot different, but it is a lot different. Of 1,0072 what. Don't round off. You still need to minus with 1, and then you're going to get 0,0725. So now what I did with the other class here, and that's why there's so much scratching here, you can decide. Somewhere you've just got to say, take it back to per year. So if you wanted to first say, let's take it back to interest rates, you could have. If I did what I did there, it's 0, I timed with 100, so that's going to be 7,3 per month. Percent. It's 0,7, it's not even 1% per month. Are you with me? You can do that. And then you can take it to per year. Or the normal thing is to time it with 12, because it's per month, and you time it with a 12, and you get 0,087 what per year, or per annum is the better thing for the English. Per annum or per year. So that you've got 8,70, and now we always keep it to 2 decimals, right? Would I not give you a mark if you don't write the 0? That's not what it's about. You will not lose so many marks. They could decide somewhere in the financial maths to penalize you for rounding, but it's not everywhere. Okay, so try and make it as accurate as possible, but they're not going to penalize you everywhere. And that sounds okay. 8-ish% for 6 months, that'll take the 18,000 to 19,000. It wasn't a lot of time either, so that was why there's not such a big increase in the amount. Second part of the question said, take this interest rate to an effective interest rate. So they're testing whether you know the formula. 1 plus I effective is 1 plus I nominal over M. Okay, we had a discussion in the other class. Please remember that M is what?
Months.
Is M months? M is? How many times? It's compounded in?
Whatever time period you give me.
1 year. Because the discussion in the other class is, ma'am, shouldn't this M be 6? Because it was a 6-month period. No. It is a 6-month period, so working with calculations, you would say 6 months. But this is why this is not N, this is M. And that M and that M has to be the same. You can't have a 12 here and a 6 there. So what, again, is M? It's how many times in one whole year would you work out interest? Because it's monthly, it means 12 and 12. Now you're going to say, but remember, there wasn't even 12 months. It was only 6. Yes, but to take effective to nominal, nominal to effective, that is always how many times in one whole year. Even if it isn't 1 year, even if it's 20 years, I don't care. It has to always be how many times per 1 year. Okay, recapping on grade 11. And then the sum has to be done where you will get your effective I and then your R effective. So you've got to take this whole thing and punch it into the calculator, minus it with 1 to give you your I effective, and to get from I to R you've got to times it with 100. 9%, 9.06, 9.1. Please remember that the sums usually say in the beginning of the paper, round off to 2 when necessary. So we stick to 2 all the time. If you said 9.1, it's not wrong, but please do what they ask you. Okay, per annum, per year. Okay, then we get to question number 6.2. Question number 6.2 was about a guy that bought a laptop. They say that the laptop is worth 10,000. They want to know how long, because the question was about M, how long will it take this laptop that was worth 10,000 to become zero? So there was value depreciation. I like to sometimes have the answer on the board and then ask you what was this question. So it had to have been value depreciation. Which value depreciation? Straight line method. On the straight line technique, they can even say in a simple interest depreciation, but this is what they said, in a straight line method. It's the first time in however long that we've seen something like this. So it's simple interest. The interest is 20%, that's a lot. Okay, so it's 0.20. There's never ever in simple interest is it monthly or quarterly, because that's compound interest, and they want to know how long it's going to take for this thing to become worthless. Now technically to me that can actually never happen, because even if I've just got the casing falling apart, it's worth something. Are you with me?
Yes,
Just like if you ask when will your car that's scarcely running and you're always trying to get it started because the battery never works and the spark plugs and the car, it's never going to be worth nothing. Right? So we've got our answer after, and what happened to the 10,000 here? Because you divide by 0 and it stays 0, and we're working out our M. Calculator, 1 divided by 0.2, just do it on the calculator, you see 5. So it would take you 5 years for this laptop to become worthless. But that's the question. Second part of the question said, I'm going to start saving to pay for a new laptop. I'm going to start saving, that's a F sum, right? To save for a new laptop, which this guy says is going to be worth 20,000. I don't care where you got that from. Could have been some estimations and you went and looked at the prices and you did some value appreciation, but he's saying if it was worth 10,000 5 years ago, I'm going to try and go for in 5 years time that this is going to be worth 20,000. I don't know where he got that amount from. They say he wants to buy in 5 years time a laptop of 20,000. How much will he have to pay for it? That means X. Okay, now the thing about the formula here is, when you read through the question, they say, I want to know how much you must pay. The interest rate is, read to me what it would say, 8.7% compounded monthly. Where did I get the 60 from? So if you read the question, they said, he makes 60 installments. There was no wondering about this. Okay. They did have some dates there. They said, on the 31st of January, he decided he wants to do this, and his first installment is going to be on the 28th of February. So there is a gap, right? Which is the normal F sum. But any which way, whatever you chose, maybe you chose the wrong formula, but 60 is your end. Because they said there are 60 installments. There's no way about it. They're never going to give you a mark for anything other than 60, because there were 60 installments. They want to know, I want to save up to 20,000 in 5 years, but there are 60, so yes, monthly, 60 installments. Interest rate, work out your X how. So we calculated all of that and divided 20,000 by it, and it came out to not even 300 Rand a month, which is good news. In 5 years, that should be. Now, again, just tell me, why isn't 267 times with 60, is that 20,000? It shouldn't be. It should be less. Because if I start paying 60 times the 267, it should be less than the 20,000, because the formula makes room for the interest that the bank is going to give me. It's much less than 20,000 because I'm putting it into the bank. Right. Question number 6.3 of this question paper, 2023, November GDE, right, said, Tino wins the jackpot. Yes, 1.6 million. He then invests this winnings, all of the winnings, in a fund that earns him an interest of 11.2%. Well done, Tino. Not just going to McDonald's and some city and I don't know where on a cruise. He invests it. And at 11%, which is not bad at all, compounded monthly. Do you see them monthly, everywhere? Don't think that they won't do anything else, but a lot of it is monthly. Then he withdraws 20,000 from the fund at the end of each month. His first withdrawal is exactly 1 month after he puts the money in there. So he's putting the money into the bank, 1.6 million. He starts withdrawing 20,000. After 1 month, he minuses with 20,000. After another month, he minuses with 20,000. And he's got an interest of 11%.
11.2
monthly. And I want to know, how many times can he do this? If sum, P sum. It's a P sum. But it's a weird P sum. It's a straightforward P sum once you know that it's a P sum. Because what is the 1.6 million?
What he has now.
Present value. We think P has to be a loan. You know, who's learning? Am I learning from myself?
No.
If you want to think about it that way. I am getting 1.6 million, and with it, I'm putting it in the bank, taking 20 away from it. But the fact is that this is my present value. Will that be all that I can withdraw? Because then the sum is easy. 1.6 million divided by 20,000, because they say I want 20,000. And that's going to be 80, I think. Is that the sum?
No.
Obviously not. That's why I went to the bank, because they're going to give me some interest. I'm putting the 1.6 million in, and I want to know how many times can I withdraw. You have to focus on this, finding the fact that that 1.6 million is your present value. And it's like you're drawing it, the bank is loaning it from you if you want. Or if you're getting money from yourself as the bank, for instance. So you need it to be a P sum. And a P sum is always gap in the front. That's why they say you put it in there and your first withdrawal is the next one. Otherwise, again, you could have just as well kept 20,000 for yourself for this month and then started taking 20,000 every month. It would be the same thing. You still have to have the gap in the front. But the thing is, I want to know what N is. Formula. Okay, I know that the interest rate, and that would be independent. Whether you use the F sum or a P sum here, your I would be independent. And your N is obviously going to be what you're going to be working with towards how many times I'm going to get 20,000. The P is the 1.6 million. Please don't have too many or too little zeros. X is your installment. Doesn't work so lekker, right? You're taking out equal number of money, 20,000, 20,000, 20,000. So it's going to be more than the 80 times because of the interest that I'm putting it on. So it's a weird sum in the sense that it looks like It's future value. I'm putting it in the bank. I'm earning some money. Yes, you are. But if you are taking out 2020, it's like you're loaning it from yourself. And at present, you've got 1.6 million. How many times will I be able to get installments? It's not quite the right word. At an interest rate of 11.2% for 12 months. And I want to know what is
N.
N. And I was waiting for this because in financial maths, this is it for a whole paper, about 12 to 15 marks. There has to be a log sum, finding N. Whether it was with the grade 11 sum or whether it was with the grade 12 sum, I want N by using my logs. The trick to the sum was P, not F. Okay, because it's like you're learning it from yourself. The best way of explaining it is, that is my present value, but it's going to grow. But I can't just grow 1.6 million with the amount of interest because you're taking out some money. So there's less for the second month, and taking out money, and there's less for the third and the fourth, etc. That's why we're treating it like I'm loaning it from myself. Okay, so doing the sum helped me. I'm going to have to get the calculations done. That has to go first. So whether you first divide by 20,000 or times by the fraction or do it all together, you're going to get an answer of
56 over 75.
Okay, and leave it like that. You can write 0, what, that's fine. But leave it like that, 75, looks like an 8. And then on the other side, we've got 1. The big brackets can fall away. 1 minus the bracket minus N. If we add this together, calculator gives me
12112.
757.
Okay. If you add that together, that gives you 757 divided by 750. Then it's up to you. I'm showing you my preference. I like to make this positive, so that it's 757 over 750, but I don't like that because that N is just by there. It has to still be in a bracket. But it was a minus bracket, it's now a
Positive.
plus. On that side we've got 1 minus the 56 gives me,
19.
and then I can get to
Logs.
logs because I've got a power base exponent. So it's going to be minus N is equal to
Log.
log,
Base.
which base? Base stays base, 757 over 750, and on that side, 19. And you can write it in brackets, it's fine. This is the base, and we're getting to N's answer. Please remember that N is negative. So this answer should be a negative when you put it on the calculator. You don't have to write it. You can immediately now go for N's answer, which was negative what? Okay, please give me more. 7?
9, 7, 6, 8, 8. That's it.
Is that it? Okay, because there's no more space.
There's an 8 in between the 7 and 6.
Okay, and there's actually more, but the calculator only has space for that. This was not the question. I'm putting this there because I'm going to add something. The question says, how many withdrawals of 20,000 will you be able to make?
147.
147 times 20,000 withdrawals. Normally we would say, but round it off, it's 148. There isn't 148. We'd like it to be, but there isn't. There's 147. Whether it's 147,000, there was 147. If this was 147,9999, there isn't 148. It's only 147, and that was the end of the question paper. What could I have asked? What is the amount left? It's like, let's change the sum around for ourselves. If I said, you loan 1.6 million and you pay that, how many times will you have to pay? I'm asking now, what is the after 147 months. So I want to know what's left of the 1.6 million that I still have to pay if this was a loan, or that's still there for me. Because it can't be a whole 20,000 because it's comma 7. But it's quite a lot of the 20,000. It can't just be 800 or 1,000 rand. It's got to be more. What do we do if I ask for the outstanding balance? A new P sum. Starting with gap there doesn't really make sense because our N
0.7978688.
Okay, that's why I wanted you to write all of that. It wasn't necessary there. Okay. This is now the N with the gap and all, but what is the outstanding balance? Where's the outstanding balance? Here is the new P after 147 months. That's what's the present value at the 147th month, which should be less than 20,000 and shouldn't be too little. So let's do the new P sum, which just feels like a lot of waste of time, but they do ask this, P and another P, because you can do this with the F sum as well. You'll see it in your memos. I teach you, do the new P. Are you with me? I don't want to confuse you with different techniques, but if you understand it, you're allowed to use it. Okay, over I, and now guys, I'm just going to save some space and say this was 0.112 over 12. This now, the N is going to be 0.7978688. Your 20,000, but ma'am, there isn't 20,000. Remember? It's still in this contract where X used to be 20,000 and I'm trying to find P which should be less than 20,000. And the I, so that my P would give me a certain amount. Help. How do I do that? Just in your calculator, all of that gives me just read it for me. 647, so comma 6. 5, what's that? That's the money that's still there in the bank waiting for me. After I took my last of the 147th time, 20,000, 20,000, 20,000. It's not 20,000. But now I can either say, okay, well, just give it to me. Or I can say, okay, I'll get my last installment from you guys at the end of the next month. Will that be what I get? No.
What about interest?
You'll have to put on 1 month's interest. And that would be for 1 month at an interest rate of, okay, let's just do this. So it's 15824,65, 1 plus, still the same interest rate, but it's now for 1 month. And the answer is please?
15,972.
It's not a lot, but it's something. 3, 5. Okay? Depending on whether you rounded it off or not. We're not going to split hairs about that. It's a little bit more, but they have to give me my interest. That's the end of financial maths.